Hi everyone, my name is Pavel, and today I'm going to tell you about IntentDot. But first of all, let's start with the challenges. So you, especially if you are new in the Web3, you will face with a lot of different applications. And these applications have their own functionality, own user interfaces, experience, and you need to deal with all of them. But sometimes it's really hard. Also, you will face with no alerts or notification that something is not right. That's why I decided to combine all the functionality and risk scoring together, and let me introduce you IntentDot. So actually you just need to write your intent, and in a couple of seconds after AI analyzing, after smart contract analyzing, your funds will be with you, it will be swapped or breached. So let's check it together. First of all, you need to connect your wallet. And the second step is just to write your intent. For example, you would like to swap $10 to USDT. In a couple of seconds, you will see transaction preview, and you have 30 seconds to execute it. Otherwise, you need to refresh the quote. And you can see this page with AI analyzing. Here is the useful information how we do analyzing. We're actually checking slippage, price impact, pull drain, and if it's okay, we can allow you to confirm your swap. So let's confirm, and confirm transactions. And in a couple of seconds, you will see swap successful pop-up. And also you can see this on-chain verified page. And what does it mean? Actually, it's our smart contract on Rust that analyzed everything under the hood. So, in the nutshell, the front end communicates with EVM smart contracts through AI layer that parses natural language into transactions. And when a user approves a swap, actually the EVM contract, before executing anything, makes a cross VM call to Rust risk engine running on PVM. The risk engine scores the transactions by price impact, MA20 deviation, volatility, and returns a risk level back to the EVM contract. And if the score is green or yellow, it means that swap persists successfully. Or if it's red, the transaction will be reverted at the smart contract level. So there is no way how you can avoid it. Another example is bridging token. So let me introduce it as well. Talking about bridging, so the bridge uses Polkadot's native XSM protocol, and when the user says bridge 20 pass to relay chain, actually the front end, and calls the version XSM message and calls the XSM precompile system level contract build into Polkadot hub, and it triggers a teleport, passes bird on the hub and minted on the relay chain. So it's native cross-chain transfer between trusted Polkadot system chains. And let me show it in action. So here in a couple of seconds after we approve and confirm bridging, we will observe the new event. And this is our current balance of my account. And let's bridge. After confirming in a couple of blocks, as you can see successfully, you will see that balance should be changed. So it should be in a couple of blocks. Yeah, it's changed. Everything is okay. And here you can see this event of minted token. So what's next? I already told you about how does it work under the hood. So actually Rust contract scores the risk based on different parameters and give you the resolution. Is it safe or not to execute? And if it's not, actually it will revert your transaction on the contract level. And talking about cross VM architecture, we do have front end that was built on Next.js plus WAGMI, and it calls AI layer that actually intent parser. The next layer is event solidity level that contains different smart contracts. And here, this the cross-beam architecture that we are calling risk engine on the Rust level, and waiting for response. And if it's safe, we can execute on the EVM level. And so, for example, swap will be successful. And everything that I told you was built on the Polka.hub testnet. So what's next? In the nearest future, I would like to introduce you multi-pool correlation. And in case of something is not right in one of our pool, for example, .USDT drops, but .USDC doesn't, it's likely manipulation in one of the pool. So not a real price move. Another one, it's Oracle price feeds, and it will compare on-chain pool prices with external Oracle, for example, Chainlink, and large deviation means pool is manipulated or stale, extra safety signal. Another one is dynamic risk thresholds that actually it will be adaptive risk thresholds based on pool maturity. If it's a new pool with low liquidity, it will get stricter limits. Otherwise, if it's mature pools, get more latent scoring. In the version 3, we'd like to introduce you NAV protection on-chain, and it will detect front-runner and sandwiches attacks on-chain. And Risk Engine flags suspicious transactions ordering patterns and protects users automatically. Another one is cross-chain risk via XSM, and it will send risk score to the other parachains via XSM. And it will be risk as a service across the whole Polkadot. And the last but not the least, it's governance risk parameters and move risk parameters such as weights, thresholds into on-chain governance and community votes to adjust in scoring without redeploying any contract. That's all from my side. Thank you for your attention.